Okay, here we go with week 10 phase manager. And you're watching this video right here, this PowerPoint. So a couple of reminders. I'm taking your attendance here by either online or in person. And I want to note that there is a quiz at the end of this. The quiz is over PID, that we talked about. So I can go ahead and put that right in here real quick. I got my new handouts, my guide sheet, my homework lab. The D2L reading, I've got some wonderful D2L reading, a few hundred pages about state managers, phase managers, state machines. So take a look at that. Last week there was some reading of some state machines, and I hadn't actually opened that up. I realized that was closed. So and so that you can go back last week and take a look at this as well. So my question was, I forgot to release. I didn't release the video for this, so I was wondering, if you were able to watch the video or not. And I looked, and I did have 12 views on the video. Now I got a lot of followers on my YouTube channel, but I don't know how many fans I've got. So was that 12 students from you guys? Did you find it or whatever? And so I'm just going to do a little test right here. If you actually are watching the video here, can you send me an email just with the word popcorn in the headline? That way I'll know that you watched it. I'm kind of curious. It really is up to you though, but send to watch it, but send it to me. Okay, we're going to start with our review of state manager. Okay, so we did the state manager last week, and then we're going to build into the phase manager this week. And the state manager was a way to control, the sequence of operations of your processing. And, the issue is when you get into troubleshooting some code that you didn't write, it can be kind of confusing to understand the state and the phase transitions if it isn't organized well. So when you write code and you have state and phase transitions, hopefully there's a lot of documentation there to help the next person figure out. And we'll look into, the different options, of how this works. So remember, this is just old. We've touched on it in 260 and 261, and now again in 262. We have, sequential control, which is, not necessarily multitasking. PLCs are good at this. Robots are good at this. It's where one step after another step. And the steps they're showing here is the filling operation, where you have to fill the bottle first before you put the cap on it. These must occur in sequence, okay? And we do a lot of that with PLCs, okay? And that's kind of what we're talking about. But there is also combination control, and I like to refer to it as multitasking. PLCs are good at multitasking. Robots, for example, are not. They're pretty much sequential the way they're programmed. And so when you hook a robot to a PLC, then you can have that robot do combination controls. And the combination control is here, where, excuse me, you might be putting a label here and a label here. It doesn't matter the order of the labels. They're both tasks that can occur at the same time, or one and then the other, or this one and that one. And so when you're doing combination controls into some type of sequence or phase manager, you can do that. You just be aware, of what your operation is and how it's working. Excuse me. Ars Logix. So I'm going to probably cough a few times during this. So what we've so far examined is the state manager. And the state manager is just real simple. We initially started learning about this. Completion of one action enables the next action, okay? And then we revisited the 260 capstone for this one. We put that into a process manager. And this is a completion of a process enables the next process, often utilizing some type of an equal and a state, and then state values to enable the rungs. A more complex state manager, if you would. And we call that a process manager. And then we'll talk about the phase manager here in this lab. And it is built-in functionality of the state machine. Okay, so when we did the state manager, and remember here I've got this plus system I put in there because the system was kind of our ultimate state manager. And if you look right here, this is a system light. So this system light is or system bit is tied up there to your main system, that your main system has to work in order for this stuff to work. And if your main system goes down, it resets any kind of latches or any kind of memory that you have in there. So that's maybe the highest level of a state manager. But in this state manager here, not only, so if we take a look at this rung, it's got a system, but in order for this extend limit switch to be indicated, and for the extend limit switch to be applied in the program, it's got a retract timer done here. So something has to occur here, some type of a process, meaning this timer gets done in order for this extend limit switch to be able to be used in the program. So it looks like this is some type of a stamp zone that is extending and then retracting and extending and retracting. So we don't want the extend, likely we don't want the extend limit switch to be active unless we had sensed it had retracted, and we don't want the retract limit switch to be able to be used unless we know that it has been extended. And so those are like our little state managers in here, and they were in those we're using our timer so that it could extend for 2 seconds or retract for 2 seconds. One of these would be an extend and a retract timer and a reset. So that is the state manager that we did in 260, and then we applied it into the process manager. Now, in the process manager, like I talked about, the best way to do it, or a lot of ways you'll see it, will be an equal sign. So we'll see. We'll talk about this tag right here, sequence demo, sequence number, where we're going to put in the state of where we're at. Is it 1? And I talked about you want to, I just see people doing, 1, 2, 3, 4, 5, 6, and that's okay unless you need to add another sequence in there, in the middle of those, and then you're like, dang it, I didn't leave a space. So, I often do my sequences as 5, 10, 15, 20 in case I need to sneak something else in there and I don't have to then go through and renumber everything. So here's the process manager. Once again, it's equals. This is my system here. Actually, it's 0. And I did put my system logic right here. And then, when this gets done, then we moved the 1 to the sequence, and then we'd be looking for equals from there. But like I said, it might be better to move 5, then move 10, then move 15, then move 20, whatever, just so that in case you got to add something. So when we do our process manager, where are you putting the logic? So you could do, I call this internal logic. So here's my equals 1, here's my equals 5, like I was talking about, then equals 10, 15, whatever. And inside of the I call this internal logic, because this could be all in, kind of, I'm not necessarily the main, but I guess a main subroutine. But here's my step light, here's my conveyor, my sensors, my part, procs, sense, and everything is occurring, right below where I've declared my state. And then when I go and advance my state after that is done, I'm going to come here. And then once again, I'm turning my conveyor off. Now I'm extending the stamp, and my sensors related to this process are all right here. It's easy to see depending on what state I'm in. It can see what's active. Now the issue is that a lot of times these processes are going to be very big. So maybe there's a better way to organize it, because this code right here could be 100 lines of code before you see the next equal or the next step. Okay, and so I'll call this process manager external. Okay, and that is where the code is not contained directly below the equals or the state. Okay, and so what we're showing here is a subroutine called state manager. And this state manager is going to be called unconditionally, and it sets the state just within its own subroutine. So you got state manager unconditionally scheduled within main. And in here, you've got this is some data boarding. So this is data boarding. So this is the name of the state, and that is good to do as well. So we had state 1 or 5, 10, 15, 20. And so you want to associate a name with those states as well. So state 5 could be aborting, recovering, stopping, resetting, starting, executing. And then this state manager doesn't have necessarily the state manager code. It just sets the state manager and basically kind of latches on the correct state and kind of unlatches the other state that you don't want. So inside of here is where you're setting your state. And then the logic, the external logic, well, that goes into the sub. So here, before I showed you that this state was maybe putting it, state change commands, it's putting it into aborting. And then if I go into the sub aborting here, well, here's our ladder logic. Here's where we're taking a look at the equal sign. And, the logic is contained in the individual subroutines, which have your, now we're backing up again to our state manager, I guess, our equal. And even though it's like a process manager, each one of these subroutines is then going to have like a little state manager inside of the subroutine to be sure that all this code can only be executed if we're at state, if we're equal to 0, we're equal to 5, or equal to 10, or whatever. And then, all the state is contained in the subroutines, but the state manager could have its own subroutine. I don't know if you'd want to put this state manager into the main. You could, I guess, depending on how complicated it is. But it's the subroutines that are being executed based on the state manager equals to the state. Hopefully that makes sense to you. The other thing we could do here, sorry to deviate, and I don't have a slide for it, and you probably wouldn't want to do this, is have conditional calling of the JSRs, aborting, recovering, stopping, whatever, having the equals of the state, calling, aborting, calling, recovering, calling, stopping, a conditional call of a subroutine. It might work, but you just want to be careful once again, because we learned that when you unschedule a subroutine, it's going to have some retentive nature in it. So if you had something on and then you unscheduled it for the next step, if you had something on there that you didn't want, well, it's no longer scheduled. So I don't know that using the equal sign to conditionally schedule, 5 or 10 or 15, depending on what it is for these subs, would be a good idea. But hey, you see some crazy stuff out there. In the process manager, I created a little AOI here. My tag here, I could put the step timer, and I could have a variety of step timers. I've got a little array here with in my sequence, in my conditions, and that's, I think, what many of you develop. So when you're managing your process or your sequence manager, it's best to have like a user-defined tag here, right? In this user-defined tag, maybe that's what I want to call this. You could do an add-on instruction. I think I'll show you that later. But this might be a user-defined tag that's got the stuff that you need in here, okay? And to control and watch and advance all your steps and everything like that. Now, what else would you want to do? Excuse me. Yeah, I asked you in that last one to put the timestamp, so maybe when you start that sequence, you could stamp the time on it. And we'll come back to this because this week you might have some time. We'll talk about it in a minute. So if you're running ahead and you want to come back to that part C, I might want you to do that, to throw in the timestamp here. Or how about the process time? How much time is it spending in that certain step? Okay, that might be very interesting to know if you're trying to figure out how efficient your process is. You can start a timer when you go in that process, and then when you're done with it, exit it, load it up into a FIFO or something, right? You could just take this tag and load it up. Just your process results, whatever you're doing in the process, depending on if you can determine what you're making, or if you're doing a good job making it, or if you're getting some information about that process, throw that in there, okay? And then you can just kind of, stack all this up and save it, and anything else. I don't know, there's anything that you can think of that you might want to individually break down these processes and then save it. And the other thing is you can always then make it accessible to the HMI so that you can go back and say, hey, let's take a look at what was happening, with first shift or second shift, or what with this run of parts. Go back and take a look at it, and you can figure out, okay, this was processed this time, and it wasn't as good a result, and who was the operator. I mean, this would be great stuff to put into the HMI, and you could do it. Okay. Now we're going to move and start talk about the phase manager, and so this is going to be a little bit of kind of I guess a catch-up week. I got some people still getting caught up on the state manager, and so this phase manager might be pretty quick for you to get caught up / go back to this one and generate some information that you could throw in here and push out to the HMI. All right. But the phase manager is in the Allen Bradley software here is a way to simplify the processes and batch applications. Now, there's a whole standard here that talks about how to control processes, and basically you're trying to simplify the development, integration, and maintenance of these batch processes. So when you talk about a phase manager, like I said, Allen Bradley's got one here in Studio 5000, but there's a lot of other software that you might buy that's very high level, like Siemens or other Allen Bradley batch processing software or whoever, and it's going to look similar to the way it looks here because of this ISA 88 batch control standard. Now, the reading on this in the D2L is pretty intense, and it really goes into some cool stuff about how this all works and the logic behind it all. And so like I said, a few hundred pages that you can dig in and really get into it. So when you start breaking this down, the first main thing is to talk about the equipment phase, and this is a logic that represents a single task by a piece of physical equipment, and that's usually what we want. We want something to run or something to work, something to mix, a motor, whatever. And it's your automated control system, in like a PLC, but there might be some other controls that are much higher end, right? Other than a PLC, but Allen Bradley does do it. And then you got your specific hardware in to execute your task, like heating or filling a vessel or whatever. This is the gist of it, the equipment phase. This is probably what you want to work to see that you're actually doing something, okay? So you want to get the equipment phase working, all right? The ISA 88, this is what I'm talking about, where there's a standard in that reading breaks it all down about how this is organized, and you get into that reading, you're going to be like, man, this is really a lot. But hey, you never know where you might end up with your job if this is where you're going to end up, designing this kind of stuff for batch manufacturing. And so what this is the recipe model, right? And it breaks down the equipment into a recipe, in how that applies to that physical equipment. And it says for allowing for flexibility and modularity in batch manufacturing. So the same thing that we talked about with the state manager is that you might come up with your own add-on instruction, or you might that simulates this, or you might use the phase manager component of the software, but it's basically it's a scheduling mechanism here for your hardware operation, and it's just built into the control logic software. Equipment phase components executes a single task like venting, pumping, stamping, whatever on a piece of equipment. So you might have a executing equipment phase, right? Defines a link to the physical equipment, and that's once again that the equipment is what we want to work. You can have different parameters that get pushed in, like your target temperature or pressure. In going back to, if you build your own AOI or something like this, it can be flexible where you can use it over again and push different things in here. And what it does is it does follow a state model. That's what we did. That's what we just talked about with using a state manager and a process is the state model. And I remind you that the last week I didn't open up. Accidentally didn't open up. I know, but there is some great reading about how a state model works. And then it just contributes to the full recipe. A full batch is made up of a sequence of these equipment phases, heating, mixing, venting, whatever, and they got to be executed in order to produce the final product based on the recipe that you put in there. Equipment phase features, equipment phase objects add specific equipment phase object to logic controller. Equipment, that's the equipment that we want. A lot of times there's pre-state and active states that you want to go through in some good ones here. And you can imagine it: idle, running, holding, restarting, related to this. Like when you stop a process, it might not be an immediate stop. It might be, and it might not be an immediate just start right up. It might require some restarting. And I could use the example of a robot. Just because you stop that robot, it cannot stop immediately. You might have to depart from the work cell and move to a safe location. And when you go to restarting, you might need to check the status of the work cell before that robot starts moving into what it's doing. And so it might take some time so you don't destroy the robot. And so you can only have one active routine running at a time, and because it might take a little bit of time, whether you're running or holding or restarting or whatever. So your phase commands, it's built into the software. Your phase commands does your scheduling for you, and these are PCMD, PSC, for example, for the PLC, for the start and completion of the phases. And then these are the tags, or these are the instructions right here, the PCMD and the PSC, that are used to communicate with the HMI or your batch systems. And that's the big thing that we're going to do here is get this phase manager to talk to the HMI, because that's really that's really the core behind all this phase manager, is that the HMI that does a lot of the work. Diagnostic features, obviously, you can take a look. When you generate this equipment phase, it's going to give you the opportunity to look at all this with the HMI and your fault routines and stuff like that. Okay. And so this is some of the stuff that we've talked about in the past, but we really haven't got down to it. But the controller level is what we're going to be working with. And really, we're just talking the Logix controller, our devices, our control, our alarming, our messaging. And that's going to be good for work cell. But a lot of this phase manager stuff is bigger. It might be used in a SCADA system where you're looking at huge facilities and you have HMIs that can really dig into what is going on in your facility. It can be much bigger. So you got integrated back system, standalone capability. It can be standalone, non-back sequence operations. It can be very simple. That's kind of what we're doing here, or it can be very big. And like I said, they got factory talk batch would be a much larger system for Allen Bradley. So some best practices when you're programming: isolate phase logic. You want to keep your logic contained in the respective phase routine, like running is going to be one. To keep it better organized in troubleshooting, absolutely. It says manage state transition, ensure the logic and robust transition between phases prevents synchronization issues. And so when you transition from a state, we learned that with a state manager, for example, the process manager that we did before, we were using a one-shot to be sure that the transition occurred in just once before the state was advanced and it moved to the next state, so that it wasn't confused. When you're using the phase manager, as I stated, it might take a little while to jump out of one phase and go into the other phase if the robot is recovering, or if the work cell is recovering, or if it's restarting or something like this. And so you just want to be sure that you do manage your state transition so that and so the phase manager it is a way to organize your process. Um, and it says for very simple sequences, a basic state machine might be sufficient, and that's what we did. But we are going to use the phase manager here for a basic machine. I know you wouldn't normally do this, but we just want to get an idea of how it's work. It says utilize AOIs for reusable code blocks to simplify this. So if you really get into a lot of phase management, you have a ton of AOIs. Here's some common phase states. Idle, you're in standby state waiting for the start. Sounds good. Running, the phase is actively executing its tasks. So remember, when you go from running to not running, it might take a while. Complete, the phase has finished its task. Holding and held, a temporary non-critical suspension of the batch. And it says when you go to holding, it might take a second. The robot might have to depart, or the process might have to wind down for a second before holding is completing. Same with pause, temporary hold. Stopping or stopped, if you're stopping, it might take a second, or it might, maybe not, maybe it stops immediately. We'll be doing a simple one, so I'm imagining it will stop immediately. Aborting or aborted, emergency shutdown that terminates the batch and maybe put equipment into a safe state. So this is one that often takes a while. If you're aborting the process, because you got to put it into a safe state, it's going to take a while. And then restarting, if you're resuming, once again, it might take a while if you got to bring stuff up to temperature, you got to move certain parts into place and everything like that. Okay. So we're going to talk about the phase manager versus add-on instruction. So a lot of people, programmers make an AOI state manager. That's what we did, and they said it could be used for a simple process, or it could be used for pretty big processes actually. But they've got, an AOI state manager here, and they've got all their different items here, and they got the state: 1 recovering, 2 aborted, 3 stopping, stop, whatever. And so I said a minute ago that it's good to have the state number, but it's even better to also equate a string here, stopping, stop, resetting, with the value of that state number. Okay, and so inside of the AOI, you can imagine there's a lot going on here, but here's your pushing you into state. If it's equal to 1, you're aborting, aborted, recovering, whatever. You can imagine what your state manager might look like in here. And now the state manager could be its just own little JSR, because we might take the state 1 or the string aborting, and that might initialize code in the aborting subroutine. And number, the aborted, these could be in the same subroutine, I guess, or the resetting. Maybe there's a subroutine called resetting, or a subroutine called starting. These could be the state managers, as shown here, inside of your subroutines. A lot of different ways to manage this. Now, the phase manager is different than this. You don't need, starting, aborting, receiving. You can make these different phases in the phase manager. And so when you go from one state to the next, from let's say you go from running to stopping, you just move into that phase, and the scheduling is done by the control software, not by your ladder logic, or not by your state machine here. The state machine is built in. And so here's what it might look like if you have different, depending on your different states where it's idle, and then you would click start, and it would go into the running, and the ladder logic and stuff that would be involved in there would become active, and it would become scheduled. Okay. And if you went hold, you'd go into a holding sub, and this would become unscheduled, and then the ladder logic and stuff that you have in the holding or the held, the restarting subs, these things would become active. You don't have to schedule them. You just use the HMI to jump between the different states of the phase manager. In the sequence here, like I said, that documentation that I gave you breaks this all down to the infinite finite level. of, of how all this could be, mixed and matched. So we're going to mess with a phase manager, and just for fun. It's me a little catch-up lab. Those that are pretty caught up, this is going to take them like, it'll be a short lab, okay? The phase manager is demonstrated here. I'm not going to do it. You can watch it. But basically, this video is what you're going to do to start the lab. You're just going to watch this video, and you're just going to build up the phase manager. And then I'm going to have you throw just some really basic code into the phase manager. And then I'm going to have you use the HMI to jump between the phases, okay? And we'll put in some timers there to indicate that we're resetting or we're restarting or something like that, just to get a feel for, how this phase manager scheduling works, all right? HMI, once again, is a big deal. It's common HMI input output would include your safety reset, status verification, validation, error messaging, process monitoring. So you can, before you start your process, you might verify that you're ready to go on the HMI, click the button, and then the HMI will move you to the correct phase, and it will schedule automatically the phase manager to run, what you got going, and keep you posted. So it's not much there. You're gonna have to dig into the lab here to see how the phase manager works. We're not gonna, even though I got all that great reading for you, it's really good reading. I'm telling you what, a couple hundred pages. You're gonna love it. If you want to take a look at it, it's just out there, just in case you get into something over your head someday where you're like, okay, I got hired for this job, and we're doing big batch processing on a big control system, and you start looking and you say, you know what, man, I've seen this before. I kind of get it, and I understand the gist of how it's all going to work and how it's going to integrate with the controller and with the HMI. That's really the goal of this one. So that's what I got. There is a quiz. Go and take a look at it, and we'll have, I think, a short lab. See you soon.